So as I was saying, Euler just makes a tangent line for the equation. Remember that if I have, let's say, a point, f of x equals y, and we have some point y naught. Let's go ahead and put t so that we're consistent. So we have t naught, y naught. So this is some value, and remember I can write that as t naught f of t naught, because y is just this f of t equals y. So this is some function. If I wanted to do a slope formula, we could do something like this. Hopefully this all looks familiar to you. What is m? It's the slope, right? So, but that is just the derivative. So I can write this as f of t naught. That's my derivative. I'm sorry, I meant to put t's, not x's. And this is my derivative, right? So I can write that as f prime of t. So now if I wanted to estimate this, I'm going to use the slope at this t value. So this is just a slope formula, right? But now I'm going to plug in t naught because I have that value for my slope. I'm going to go ahead and add this over here. And so then this is just my change in time. So this is the derivative, the rate of change, times the change in time, times our current value, or plus our current value. Notice this is exactly what we did in the last equation. What we're doing is we're just estimating the next place in the derivative. Instead of solving it, we're just using the derivative to find these values. So we're basically just taking tangent lines and making a step. So the tangent lines are correct, but the farther off we go, the more likely, so see, I'm trying to match these tangent lines, but see, the more and more I get off. But this can be still a very good method. And so what we do is, notice I iterated it, meaning I repeated it over and over again, and we usually pick the same change in time. So we're going to change this to be delta t, so that each time period is the same. So what we end up doing with Euler's is, so this iteration number is to count the next value. So it's like, so t0, t1, t2. It just means the first time period, the second time period, the third. I'm starting at 0. And we can do that with y's too. y0, y1, y2. It's just saying which one goes next. And so I can write this as a recursive formula and say that I can find my next y value. So we'll just say I from my previous time period, I minus 1, times delta t plus, so this is the derivative, times my original function from the previous time set. So this is what Euler's formula is.